So, yeah, we need to talk about radical expressions. And the radical expression basically just means it has a square root in it. And we'll talk about different, and we talked about some of them last time, and we'll probably review some of that today. But the first thing has to do with adding radicals. And the principle on adding radicals is similar to adding like terms. You know, when we have like terms, let's figure that. Okay. So this, and for y'all that weren't here last time, yeah, so I do the examples, but I'm going to add to them, the ones that are in the notes. I'm going to start before the first one. I've got several that we're going to go through. So anyway, hopefully if you have room there, but you might need to supplement it with other pieces of paper. So yeah, we're on page 5.
Oh, okay.
Yep. And yeah, so the principle here, so we have like terms, don't we? How do we know it's a like term? Well, it's got the same variable, same power. And when we add them, so what do we do when we add like terms? You just add the numbers in the front, right? And so that's 15x, the x stays x. We only change it, the power of x, if we multiply x's, right? X times x is x squared, but x plus x is just 2x. We got 15x, and then subtract 2, you got 13x. Okay, so the principle, and then if we have 4x plus 7y, what do you got there? You got nothing, right? You can't simplify that.
No like term.
No like terms. Okay, so the same idea applies on radicals. You have to have like radicals. What do you think that means? If like terms mean they have the same variable, like radicals means they have the same radical, the same square root, or cube root. We'll deal with square roots, but like radicals have to have the same radical. So when I have 5 square root of 2 plus 6 square root of 2, you got like radicals, because the radicals are the same. You got the same square roots. Okay? Now, what do you do when you add them? You do the same thing you did up here. We added the numbers in the front. Well, subtracted. We added or subtracted the number in the front. So what do we add here? 5 and 6. So you got 11. And then what happens to the radical? Same thing that happened to the add. It didn't change, did it?
No.
Okay. So when you add and subtract radicals, the radical doesn't change. All right. So when we go to 7 square root of 3 minus 10 square root of 3, and then let's add one more to that, plus square root of 3. All right. So we've got like radicals. All of them are like. Square root of 3, square root of 3, square root of 3. So I can combine all those. So I've got 7 minus 10. Of course, that's negative 3. Let's just do it this way. And the radical still stays square root of 3. Now let's talk about this one. It's a like radical to that, but it doesn't have a number in the front. What's the number in the front, though?
Is it
1.
It's 1, yes, absolutely. The number in the front is understood to be 1 there, even though it doesn't necessarily, it's not necessarily written. There is a 1 there. It's understood to be 1. So we're combining negative 3 plus 1. That gives us negative 2.
Where did you? Okay, never mind.
Negative 2.
I was trying to figure out where you got negative 3 from, so I see it now.
Yeah, those two combined. And then, so we got negative 2 because you got negative 3 plus 1, and then square root of 3 stays the same. Good? All right. What about this one? 8 square root of 5 plus 3 square root of 7.
You can't do anything.
Can't do it. All right. Why not? It's like this, isn't it?
Yep.
Doesn't have like radicals. All right, so you can't simplify that. It's not like radicals.
So that's going to be the answer?
That's the answer.
Okay.
Yeah. Kind of a trick question, isn't it?
Yeah.
Because you have a problem, you always, I gotta do something. No, you just can't do anything to that.
So on the quiz, you will almost write can't simplify.
Can't simplify, yeah.
Okay.
Yeah. That would be good. Otherwise, if you just leave it blank, you just skipped it, you know?
Yeah.
But anyway, yeah, can't simplify that. Now this one, what do you think about this one?
Wouldn't that be the answer to, or no?
Can't
no.
simplify also? Is that what you're saying? Can't simplify?
Yeah.
Why not? This one's square root of 10, and to combine it, I would need that to be square root of 10, wouldn't I? Does that have square root of 10? No, it does not. Even though that 6 is right, plus 3 is right there, that's very tempting. Can't do it. Can't do it. And that one will probably come up more than that one. Usually, we get to this, there's some work and we get to this, and so my point in showing you that is, you can't simplify that because it's not like radicals. That's a radical, so that's got to be a radical to the same one. Okay, good? All right, so that gets us then to that Roman numeral 7 there, finally to that, and it says to add or subtract radical expressions, you have to have like terms or like radicals. And so when we get to that one, square root of 48 plus square root of 27 is the first one on the top of page 5 there. It says that simplifies to 4 square root of 3, 3 square root of 3. So that's where that was last, we did that last time. Simplified those, but let's work through it. How did we get 4 square root of 3 out of that? Well,
Factor.
yeah, factor, you got 48, 16 times 3 is a factoring of that. There's others. And this one is 9 and 3.
3.
Okay. And the reason we factor it that way is because, you know, like we said, you can split apart square roots when they're times like that. And like I said, we went through that last time. There's some on the assignment 1 like that. You can split those up. If it's add, something like this, you can't split those up. But that's because it's add or subtract. You can't do it with subtract either. But if it's times, you can split those up. So that's why this works. And 16 square roots nicely, doesn't it? It's 4. And so that's how he got 4 square root of 3 for that one, and then this one, same thing. That's square root of 9 square root of 3, so that's plus 3 square root of 3. And that's where our discussion now kicks in, doesn't it? I can add those because they're like radicals. 7 square root of 3. There you go. Okay. And just to remind you or tell you, you know, sometimes in math, they just want the answer. I want to show you to show your work. So show your work. I mean, it doesn't have to be necessarily every step that I show you, but show work, because that's what I like to grade. See what you did there. All right. So on to number 8. Is that okay? Any questions on that? To multiply radical expressions, we use the following note. If you've got the square root of A times the square root of B, then that equals the square root of A times B. Well, that's kind of the reverse of what we did here, wasn't it? I took this one and split it apart. This is saying, well, we can go the other way. You can multiply them together. And I think we talked about that. Doing that last time, but more of that today, okay? So let me just do a couple of examples here. So square root of 2 times square root of 3, what do you got? Square root of 6, okay? So this is, you don't have to have the like radicals on these because we're multiplying.
Question.
Yes?
So, like, I see on a couple problems on here, they got parentheses around it.
Yeah, no, you don't have to write them, yeah.
Okay.
I think he did that because, yeah, sometimes his font or whatever, the square root's kind of funky. I think
Okay.
that's why I did the parentheses around
Okay, I was
it. But
making
if you do the full symbol, I think it's
I was
not
just making
necessary.
sure.
Yes, good question, good question. All right. So you got your square root of 6. So yeah, you don't have to have like radicals there to combine. Now, we'll talk about when we do have like ones here in a second. But now, let me go ahead and do one more before we get to A. So 2 square root of 3 times 4 square root of 5. Again, doesn't have to be like radicals, but what do we do if we have some that aren't a radical or square root, some that are? Well, you're going to multiply the ones that are like together. So I'm going to do the 2 times the 4, and that's 8. And then the square root of 3, square root of 5, combine those, square root of 15. All right? So it's 8 square root of 15. It's, you know, it's a lot like the x's. You know, if I had 4x times 5x, you'd multiply the 4 and the 5, 20. The x times the x gives you x squared. It's the same thing. You're going to multiply what you can together. So I can multiply the ones on the outside, multiply the ones on the inside. Okay? With me? All right. So that gets us to A there. Square root of 5 times square root of 8. Well, if we just go with, a couple ways we can do this one, but if we just go with that thinking, that's square root of 40, isn't it? Now, one of the things that we always will want is to simplify the radical if we can. We haven't had one that simplifies yet, well, on this part. On, what was it, number 7, we had that square root of 48. This is the same boat, isn't it? The square root of 40, we need to simplify it. And so what I'll be looking for on your homework and tests or whatever is, let's call it simplified form of the answer needs to be in simplified form, which just means square roots need to be, you need to take out the perfect squares like we did on number 7 there. So let's break square root of 40 down into 2 square roots. What 2 square roots can I break that down? That would be helpful to simplify. 4 and 10?
4 and 10.
Yep. I can do the square root of 4, square root of 10 for square root of 40, and then that's 2 square root of 10. And so, like, you know, showing your work on those, that's the bare minimum, I would say, on something like that.
So you wouldn't take the 40. You would want us to simplify it all the way down.
I want to simplify, yeah.
Okay.
I always want the simplified form of the answer to be the final correct answer, yes.
Okay.
All right? B. Square root of x cubed times the square root of x. Same idea. Multiply, so I can just multiply the x cubed and the x. And the significant thing there is, like we said about the number in the front, same thing on the power. If there's not a power, it's understood to be 1, isn't it? And so that would be the square root. We'd add the exponents, get the square root of x to the 4th. And then that brings up something else we talked about on Monday. If we've got x to a power, an even power, the answer is, there's various ways you could do it, but if you just want to shortcut it, there's a simple little rule. What is it? Power divided by 2? Yeah, turns out the square root of x to an even power is just that x to the power divided by 2. And it's because this is the 1/2 power, but anyway. So the square root of x to the 4th, it's x squared. Just divide 4 by 2. That's why I've got the 2 there. All right? Question or concern on that one? All right, letter C on number 8. 2 square root of 6 times 4 square root of 3. So we just, well, I've erased it already, but we just talked about one like that. There's an extra step on this one though. All right, so we got the 2 and the 4, so again we got 8 on the outsides. And then the square root of 6, square root of 3 on the inside of the square root. So that becomes square root of 18. Why is that not the answer?
Because you have to simplify.
You can simplify that square root of 18. Always want to do that. And so we've got the 8, and then 18 breaks down. You got square root of 9, square root of 2. For 18 would be the best way to factor that, wouldn't it? Because then that's 3. Square root of 9 is 3. Square root of 2, well, that's square root nicely. So what do we wind up with? 24? Yeah, so now we can combine the 8 and the 3. Multiply. Good? Any question or concern? All right. On to number 9. To multiply radical expressions, you also might have to use distribution and or FOIL. Okay, so let's talk about that. Distributing. Let's use the x's to remind us there. What does that mean? Well, that means if we have like x times then 2x plus 7. That's distributing. What does distributing mean? We take the one on the outside and do what?
Undo it on the other
Multiply
side.
it on the insides. So 2 times x, x times 2x, 2x squared, and then x times 7 is 7x. FOIL. What are we talking about there? Acronym, right? X plus 2 times x plus 3. FOIL that out. Well, first, x times x squared. Outer, x times 3, 3x. Inner, 2 times x. And then last, 6. So, yeah, that's what he's referring to there, distribute and FOIL. And then, of course, and that will happen too. We combine the like terms. And over there, we can't combine those, they're not like terms. So, same thing's going to be for the radicals. So, he has a. What are we going to use there on a? 3 square root of 2, parentheses, 5, plus 2 square root of 2.
What did you distribute?
That's distribute. Yeah. So we take the 3 square root of 2 and distribute. If you have a plus or a minus, in the parentheses there is the kind of the trigger for distribute there. So the 3 square root of 2 times your 5. I'll write it here so you don't have to necessarily write this, but I'm just showing you what's happening here. What's that going to be?
Wouldn't it be 15 times the square root?
15 square root of 2, yeah. Because the 3 and the 5 are the ones I can multiply there. The square root of 2 is its own thing. 15 square root of 2. Now, 3 square root of 2, 2 square root of 2. I'm going to have what? Plus 6. And then what about these square roots? They're like. I still multiply them though, right? When you have multiply, you multiply the insides. And so I'm going to get the square root of 4. Now, we haven't had that happen yet. What's going to happen when I do those two that are square roots of 2 or what?
Well,
They're the
isn't the
same.
square root of 4?
Square root of 4 is 2, right? You can actually square root that one to simplify it. And so that's going to be 2. And it's understood there that that's times.
Where is it?
Question?
Oh, I'm trying to make sure I ain't missing nothing.
Okay.
Trying to figure out where the 6 come from.
The 6, okay, so that's 3 times 2.
Oh, okay.
Yep. You multiply the outsides together, and then you multiply the insides together.
Okay, makes sense now.
Good? All right. So you got 15 square root of 2, and then plus 6 times 2, you can go ahead and do that, 12. Okay? And that's going to be the answer. I can't combine those because they're not like radicals. When we've got to add, you got to have like radicals. So it had to be the square root of 2 over here also. All right? Any other question? Okay. So B has parentheses 5 square root of 2 plus 2, parentheses 5 square root of 2 minus 2. So this is FOIL, isn't it? This is where we would FOIL. Because you got basically binomials, 2 terms in each one. So that's FOIL. And we just went through one of that. So 5 square root of 2 times 5 square root of 2. 5 times 5 is 25. Square root of 2 times square root of 2 is square root of 4. Then we do the outer. 5 square root of 2 times minus 2. So we've got just a 5 and a minus 2 is minus 10 to go with the square root of 2 there. Yes? So far so good?
Yeah.
2 times 5 square root of 2, well that's similar. 2 times 5 gives you 10, but it's positive 10. Square root of 2, because you do the 2 and the 5 at the square root of 2, it's going to stay square root of 2. And then last, 2 times negative 2 minus 4. So what can we do to that? Lots of nice things happen on this one, doesn't it?
So the square root of 4 becomes
Square root of 4,
times 2.
okay, that becomes 2. You can do the square root of 4. It's nice. What happens in the middle?
You cancel each other.
They go out, don't they? Because those are like radicals. They're going to go out. Because one's a minus 10, one's a plus 10, that gives you 0. So you don't even have to write that, because it's 0. Just mark them out, okay? And then, of course, we still have the minus 4, so that's 25 times 2, that's 50. Minus 4, 46?
46.
46. Lots of nice things happen on that one. It doesn't always happen that nicely. Let me show you. This one's not on here. I think you can get it right next to it, though. B. So let's do 8 minus 6 square root of 3, parentheses 4 minus square root of 3. Let's see what happens on this one. It doesn't, nice things happen, but not as quite as nice. All right. So you got 8 times 4, 32. 8 times minus square root of 3. Well, can I actually multiply those numbers together? No. I just have to write it as 8 square root of 3, because one's an outside, one's an inside. 6 square root of 3, minus 6 times square root of 3 times 4. Minus 24 square root of 3, right? You multiply the 6 and the 4. Good? And then minus 6 square root of 3 times minus square root of 3. So what's going to happen there? Again, that's an understood 1, minus 1 there. So that's positive 6. Minus times minus is a positive. So it's positive 6. But then I've got square root of 3 times square root of 3, so I've got to multiply those. Makes it square root of 9. So yeah, not as nice happens here. We can combine these in the middle, because I'm subtracting like radicals. And so that's where you have to remember, when I combine like radicals, what happens? You combine the outsides, negative 32. That's negative 8, negative 24, minus 24. But what happens to the radical when I combine like radicals? Stays the same. That stays the same. It's not multiplying, that's adding or subtracting. So that's different than when I multiplied on the top there to get the square root of 9, you see. All right? Now, and then last but not least here, we've got 6 times what? Well, square root of 9 is 3. We can do that one. So that's 18 on the end. And so last but not least, you got your 32 plus your 18. Is that 50? Combine those. All right, now, can I combine the 50 minus the 32? No, I cannot. No, I cannot. Those aren't like radicals, so that's it. All I can do on that one. All right, so let's do C. Then we'll move on to page 6. After that. Okay. So here is another little rule.
You gotta do that twice.
You got to do it twice, yeah. You can't just square the 2 because it's add. If you got a binomial thing, that's just the way it works, isn't it? So if you're squaring a binomial like that, a plus or a minus term, 2 terms together, write it twice, yes. And so, yeah, so that's going to be FOIL again. You got 2 times 2, that's 4. You got 2 times 3 square root of 2, that's 6 square root of 2. Then you got 3 square root of 2 times 2, so that's 6 square root of 2. And then 3 square root of 2 times 3 square root of 2, what do you got there? 3 times 3? 9. Square root of 2 times square root of 2? Square root of 4. Now we simplify. So the middle 2, we got like radicals, so you can add those. So that's 12, 6 plus 6. But when you add the like radicals, the radical stays the same. So it's still just square root of 2. Then you got 9 times square root of 4, so that's 9 times 2, that's 18. So it's 4 plus 12 square root of 2 plus 18. And so then, yeah, you can combine the 4 and the 18. 22. Done? Can I combine those?
No.
No. All right, we're good. All right. Good deal.
Question.
All right.
So, so you know, on one of the problems that you gave us 2 problems ago, it had the 10 and the square root of 2, and we exited those out.
Yeah.
What about this one with the 6 and square root?
Yeah, so these don't go out because one's a positive, the other's a positive.
Okay.
A while ago, it was positive 6, if it had been the same, if this would have been a positive 6, that was a minus 6.
Okay.
Yeah, so this one doesn't cancel out, it actually doubles up.
Okay, makes sense.
Is what it is, yeah. And the difference is, we started with one's a plus, and the other one's a minus.
Okay.
So these are exactly the same, plus plus. A while ago, we had
Minus.
exactly the same, except the one we had plus and one had minus.
Okay, thank you.
Yeah, good observation there, all right.